Okay, so we're going to go ahead and get started. And actually, what we're working on first is finishing our 0, 0 notes. And that is just the example for how to use the calculator that we are required to use on the end of course exam. Did we get through example 3? How far did we get? 3? Okay, so we're going to kind of move through quickly. This should be a review. I do want to make sure we get through all of our, next time, wait until I'm not talking, okay? I do want to make sure I get through all of our 0-1 notes too, because you have homework on that, and I think I already told you, sorry, your mind sample. This is the worksheet that's your homework. If we had time in class, we would start a class, but I know we won't have time. And so bring that back complete along with your notes tomorrow. Go grab your stuff up front, buddy. Yeah, go ahead and grab them. They're right up there. So when you come into class, guys, make sure you grab your calculator. So go to your seat. So go ahead and grab calculator 9 and grab both those worksheets. Also, we sign in when we come in if we're tardy. So go ahead and sign yourself in right there. The time, look right here at the digital clock so you can put the time there. You are Emmanuel, right? Okay, I'm marking you. Okay, here we go. So you guys are telling me we finished with example 3 yesterday, so we're going to start with example 4. So we're going to be working with the fraction button. You may be great at adding, subtracting, multiplying, dividing fraction numbers, working with improper fractions, working with mixed numbers, but it's kind of thing, especially adding, subtracting, mixed numbers and fractions, because you got to convert the common denominator. It's a whole thing, right? Not necessarily hard, but it takes a lot of time, so we don't want to take that much time. When we can, we want to use our calculator to make our work more efficient and less time consuming, and also to double check our accuracy. So this section we're going to start on is this section here, and we're going to learn to use this. This button is the new button we're working with, and we're just going to call that the fraction button. If we have a fraction or a mixed number, we can use that button. It's technically a mixed number here, A and B over C, like a mixed number, but fraction or mixed number, it's the same button, okay? So if we want to multiply -3/4 times 5/8, we are going to use this button. So the way we would enter a negative is we enter the number first and then the negative button after, right? Do you need something to write with? And you're going to get out your stuff from yesterday. So yes, we're finishing yesterday's grade. So it looks like this one. Okay? Okay, so if I want to enter 3/4 into my calculator, -3/4 into my calculator, I'm going to have to enter the 3/4 first and then the negative, right? Were you here yesterday? No. Okay, so come up here. If you're ever out, there's a while you were out table right here. And all the papers you're going to need, yesterday was Monday, so Leslie, all the stuff you need is here. One of each of block. They might be kind of jumbled up because people have been getting in and out of them all day. All right, so we're going to enter the fraction 3/4. The way we enter that fraction is 3. ABC 4. So this indicates the fraction. On your calculator, it's going to look like this. 3, this little backwards, right angle. That's 3/4 on your calculator. You see that? That means 3/4. Okay, but we need a negative, so we're going to use our positive negative button. Remember our positive negative button is here. Our fraction button on the calculator is here. Okay? Write what I'm writing, remember. To get full credit, all you have to do is write everything I write and get it turned in. Okay, for your notes, the only thing you have to do is add everything I have. No partial credit. I think it's a problem. I don't give you any credit for those things that day, right? They stay untapped, but you can always go back. If something happens and you didn't get something, have somebody sitting around you, or just watch the video when you get home. You can fast forward through that video so you get to the spot you need. Okay, -3/4, then we're going to put our negative button, the positive, negative button, this button. So now we enter negative 3/4. The times button is an X, right? Now to enter 5/8, just like we did 3/4 in the numerator, the ABC is like a fraction bar of this button, and then 8, and then the equal sign. So once you get that written, go ahead and use your calculator and see what you get. Another great feature about this button is that it can also help you simplify fractions too. If you get 33/92, or 33/96, can we simplify that fraction? Well, if we can, when we put it in our calculator, 33 ABC 96, it will simplify it for you. So you don't have to go through and say, okay, well, is there a number that'll come out of both top and the bottom? Just use your calculator. It's a shortcut, okay? Shortcuts are great. And what do you get? Very good. But if you did not get negative 15/32, you need to let me help you put it in, because that is the correct answer on my board. Negative 15. All right, okay. I will tell you, it will also give that simplified. So when you use your calculator to add and subtract fractions or multiply and divide, it'll give you the simplified answer to start with. Might be a mixed number, and then if you want to turn it into improper fraction, I'll show you how to do that in the next one. Y'all kind of busy? Okay. If we want to subtract a mixed number, 5 1/4 minus 1 3/5, we enter the 5 1/4 using the same buttons. We'll just use it more than once. So 5 1/4 will be 5 ABC 1 ABC 4. That is 5 1/4. This is actually space. This is actually a fraction bar, but that would be 5 1/4 on your calculator. It's going to look like that. And we have to know that that is a mixed number. Okay? That makes sense? Makes sense? Now we're going to subtract 1 3/5, so our subtraction button. And then 1 3/5 is the same way. 1, ABC 3, ABC 5. So minus 1, ABC 3, ABC 5, and equal. So once you write it down, then put it in your calculator real quick. Make sure you know how to enter it on there. So we're practicing using your calculator. Good. Is it positive or negative? Positive. So the first number is bigger, so that's a good check. Minus the smaller number, it's going to be positive. So would you get 3 and 13 20th? Say that again. So this is a mixed number, so do you mean an improper fraction? Yeah, so I will take either one, but I do want to check out again the improper fraction. So to switch the form of that, we can do, so this would be an acceptable answer. So let's switch it. So now we're going to do second and ABC. Tell me what you get. Yeah, and so that would be the improper fraction. So depending on how you're asked to give the answer, either of those, if they don't specify, then either of those is okay. Okay? Any questions on that? We good? Now we're going to use a new button. This is our power raised to a power other than 2. So we used this power yesterday, x squared, the square button. Now we're using the power button that we could use this, we could raise it to the second power. Here's the button, now we probably would, but we can raise it to any power using this button, and this button is here, right below your off button. Make sure you find out so you know where it is. So 3 raised to the 5th power, that's how we read this. Big 3, that's our base, our exponent or power is 5, you read it 3 to the 5th power, and that means 3 is a factor 5 times. It's 3 times 3 times 3 times 3 times 3. And that's going to be a big number. We don't want to have to do that by hand, right? We want to use our calculator, and it's easy peasy. So it's 3, so your base, and then our power button, y to the s, and this whatever your exponent is, and the equal sign. What did you get, Tim? 240. What did you get, Misha? Okay. What did you get, Molly? What did you get, Jasmine? 243 it is. They're all right. I'm going to box out. If you're raising it to a negative 2 power, we're not going to use the square button. We are going to use the power button. So it's going to be the big number, the base, the power button again. But if we're raising it to the negative 2nd power, then we have to enter the number negative 2, right? Remember, always the number, the digit, and then the negative button. So that would be 3, the power button, 2, and then our positive negative button equals. What do you know about a negative exponent? What can you tell me about a negative exponent? Do you remember what? It's a decimal. Very good. Which means, if it's a negative exponent, it's going to be a decimal less than 1. Right? It's not going to be 1. Or a fraction less than 1. So you can do it, you can write it as a fraction or a decimal, but what it means, like you said, is a decimal, and a decimal means is less than 1. Right? So you can have a decimal in a number greater. So we can have 1.5. Technically, there's a decimal in it. When we say decimal, we really mean less than 1. Okay? So what do we get? 0.1 repeating. That's right. So I don't like that. So what if you can't give it as a decimal? I don't really want a 0.1 repeating answer. I want an exact answer, and this can be written as a fraction. So do you see? Let me show you one here. This bottom button here where there's an arrow. If you look right above that, it says F and D with 2 arrows. That just means you can go from fraction to decimal and decimal to fraction. So what we're going to do now is we're going to leave that number in, and then you're going to hit the second and the arrow. So this is an answer, but most likely I'm going to want you to give me a fraction answer for that. So we're going to hit second and the arrow, and then tell me what you get. 1/9 is what you should get. Okay? Easy peasy. Calculator is your friend as long as you know how to use it. Real quick. Look at 8 and 9 before we start. What's the difference in 8 and 9? 9 has 10. So what does that mean? Oh, not right now. That in between notes all together. So one has parentheses and one doesn't. Anybody want to give me something else, Misha? Exactly right. Misha's right. But it looks like they're both negatives, doesn't it? That looks like a negative 3, and that looks like a negative 3. Misha's right. They're not technically both negatives. We usually write negative 3 with what we call this negative. Technically, what that sign is the opposite. So what is negative 3? Well, it's the opposite of positive 3, right? So in this example, they wanted to raise the opposite of 3 to the 4th power. Make sense? That's what it says. It looks like this says the same thing, but that's not what this one says. This one says it's the opposite of positive 3 raised to the 4th power. Kind of tricky, all right? To be honest, I'm not going to be tricking you. I'm not trying to be tricky with anything like this because it is a little confusing. But on the ESCs, it's easily see these 2 questions, and you have to know the difference. Okay? If it gives you those parentheses, you enter it with the parentheses and raise it to the 4th power. If they don't give you those parentheses, you don't raise negative 3 to the 4th power. You're going to raise 3 to the 4th power and take the opposite sign. So we're going to do that right now. Does that make sense? Okay, so Negative 3, to raise negative 3 to the fourth power, we're going to have to use a parenthesis. We're going to have to use a 3 and a positive slash negative button. Close our parentheses. So we've entered negative 3 now. Now our power button, write the X, 4, and equal. Right off the top of your head, do you think it's going to be a positive or a negative number? Positive or negative number? What do you think? Positive. It is going to be positive. Even number of negative signs gives us a positive answer. An odd number of negative signs gives us a negative answer. What did you get? Did they get it yet? 81. What did you get? I need to start learning. What did you get, Kendall? 81. What did you get, Justine? 81. What did you get, Christopher? 81. It is 81. If you've got something different, let me know. Let's make sure you know how to use the calculator, okay? Just something, a little tweak you need to make. Now here, I don't have parentheses. So what I'm going to do, there's a couple ways you could do this. We could use parentheses, but I think the easiest way is what I'm going to show you. If there's no parentheses, let's take this 3 to the fourth power. So 3, power button, 4, equals, you know what that's an equal, right? We've already done that. Well, we did negative, so it's going to be 81. But we did not take the opposite of that. So now it's our positive, negative button, which is negative 81. So example 8 is positive 81, example 9 is negative 81. So we raise 3 to the power, and then we take the opposite side. Okay, any questions? So can we do it 40 positive nope. It'll give you 3. No, it doesn't give you the negative, right? Okay. So, we can Kyle, sign out real quick. We've got less than 4 minutes. We're going to start next time we pass you. You're going to have to catch up. Everybody pass your worksheet and your notes so we just finish up. And your 2 truths and a lie. If the front people will be next to you in your row. If you would make 2 piles for me, corners for me, take the papers from behind you. Make sure your name is on those so I can give you credit. There's a digital clock right there. Cal, you need at 124. Go ahead and get your 0-1 notes out. The pass is right there. If you wanted to pass. You're sure that's the question. I'll show you tomorrow. It's okay. I'll show you tomorrow. I can't remember what I put on the due date, but whatever I put on the due date, I'll bump it so it's not late. Okay. I did put that assignment in, and I'll show you guys how to do it. Only because we're going to almost run out of time today. All right. Actually, I took too much time yesterday, which made it hard to do. It's going to make it hard to do anything else today, so I'm going to run out of time today. Okay, that's fine. No worries. I'll take it tomorrow. You didn't do your teachers from line yet? Don't worry about it. Are there all of them? Oh, perfect. That's okay. You can do your 2 truths and a lie when you either in the class today or tonight or beginning class tomorrow. They won't take you very long. How long does it take you to do your 2 truths? A minute, exactly. It's not going to take you long at all. Okay. Okay. I'm going to try not to rush, but go to steady pace. All right. Normally, I'm going to I've been letting you just blurt out, and today we're going to continue to blurt out. If I ask a question, everybody answer me, just because I know I'm going to be pressed for time today, right? And that's kind of fun sometimes, so you don't have to stress. If you can answer in a crowd, sometimes day we're going to sort out, we won't always sort out the day we are for the sake of time. Open a new copy. Great. Okay. So, I am going to have you write some stuff on the back of your notes, but not as much as been on trying to stop my micromanaging self. All right, so which means I'm going to try to give you a little less things to write, especially since this is review. We are going to wind up writing controversial assignment, Benny. You got that in? All right, so this part I'm not going to make you write on the back of your notes, so I thought, come on, Mr. Romans, they don't have to write every single thing we say down, okay? So we are going to talk about it because it is important. It's a review. You have to be able to solve an equation. We have 6 examples. You can see here, we have a couple things we can combine on this side before we solve. Same thing here. Here we have constants we can combine. Here we have variables that we can combine. We use everything together. These are variables on both sides, variables on both sides. Some things we can combine here and variables on both sides. Some things we can combine here and variables on both sides. So when we have a set of equations that look like this, we have some best practices. There's always more than one way to solve an equation. Well, almost always more than one way to solve an equation. Okay? But I'm going to give you the best practices. If you do it the same way every time and check for these things every time, you'll have a lot more consistent success. That's what I'm going for. Okay? So if there are no fractions, one of the things I would say to do is, if you see parentheses, let's get rid of them. Probably when you see parentheses, you're thinking distribute. And you can do that. That works every time. Sometimes we might decide to divide those away. And you can do that. I say usually we distribute. But there are both 2 ways to do that, right? We don't actually have any parentheses on these equations. But if there's no fractions, I did want to remind you, that is where we start. We don't wait for to solve an equation that has parentheses in it. All right, if there are terms that can be combined, and we call those like terms, same variable, same exponent, we combine on the left side, combine on the right side, before we start doing any solving. Okay? If we have a variable term, so a term on the left side with a variable in it, and a term on the right side with a variable in it, we got to get on the same side. Before we start solving our equation. Right, so not solving anything yet. Here's where I would get to thinking we would call this solving the equation, where we start undoing operations. So real quick, let me ask you, what do you think it means to solve an equation? You know, what does it mean? What do you think of when you hear, okay, solve an equation, what do I want you to do? Find the answer? That is true. What else? How else could you say it? How else could you say it? What's the call that? I should have the other one. Quotient, okay. Oh, you might not find a product of the quotient, but you might have to find a product of the quotient to solve it. Right? Sometimes we do that. So what we want is, would you agree we want the answer? Would you agree we want the solution? What does it mean to be an answer, to be a solution? That's my question to you. So, let's look at this equation. What is the solution to that equation? X plus 2 equals 5. Do you know what it is? 3, right? Why is 3 the solution to that equation? Because 3 plus 2 equals 5. 3 plus 2 equals 5, is that a true or a false statement? It's a true statement, right? If I solve this equation and I say x equals 4, what is 4 plus 2? 6. Does 6 equal 5? It would be a false statement, right? So unless the value will make the equation a true statement, it can't be the answer, it can't be the solution, it can't be any other thing you want to call it that is referring to finding the answer, right? Finding the solution. The solution has to be the value that you can replace x with to make it a true statement. So if you think about it that way, sometimes it makes it easier to 5 people here? We don't know that yet, right? We can't do that in our head at a glance, right? So what we're doing is, if you think about the equation kind of as a puzzle and the steps that we are reviewing as your tricks to solve this puzzle, then maybe that also will help you kind of with the logic of practicing and using the steps. So I'm doing the operations that are happening to x. So are we multiplying or dividing x by something? Are we adding or subtracting something to x? Those are the things we're thinking about. So if the variable is being multiplied by something, how do we undo multiplying? Dividing. How do we undo dividing? Okay. If something's being added to the variable, how do we undo addition to the variable? Subtract it. How do we undo something that's being subtracted from the variable? We add it, right? So that's what we need to remember. You don't have to write any of these. Now, these next ones are special solutions, and I do want you to write this on the back, because kids do have a hard time remembering this. You don't use this as much. So this part here, we're going to write on the back. If the variables disappear, we should automatically know we are going to have a special solution. That means it's not just going to be a value. Anybody remember what the 2 special solutions are? No solution is one. What's the other one? All real numbers. Very good. So no solution means there is no value that you can replace x with that will give you a true statement. All real numbers means any number you plug in will make it a true statement. Okay? So that's what that actually means. All right, and I'm going to pick it up because I got 6 examples to do in 15 minutes. So if the answer is false, and that would look like this. Let's say x, that's not x. There's no x anymore. So our example might wind up looking like 0 equals 5. That's a false statement, right? 0 does not equal 5. So if it winds up that way, that is not our answer. Our answer is no solution. We now know there's not a number that we can plug in for x that will make it a true statement. And we have a little shorthand way to write that symbol. That symbol is the empty set symbol or the no solution symbol in this case. We can use it for that. Not 0, remember, that's empty set or no solution. All right, now, if it's a true statement, it's going to look something like this. 5 equals 5. Well, that is a true statement. But 5 equals 5 is not the answer. True is not the answer. The answer is what, Fiona? All real numbers. And the way we can shortcut that one, we're very bad at making it. Oh, that's my best one today. It's an R with 2 lines. Another line through it. So that represents all real numbers. This represents no solution. You do not have to remember those. You can use the words. Okay. We have 6 examples. We are not going to pack up until all 6 examples are done. So, buckle up, Buttercup. Mark? Set, y'all ready? Okay. All right, here we go. First equation. Can I combine anything on the left side? Yes, what? 9, not 93. Pretty good, excellent. Yeah, so we can take 9 and subtract 7, right? I'm going to put my variable term first. 9 minus 7 is 2, we all know, so that's plus 2 equals 8. You with me? What's 3x mean? 3 plus x, 3 minus x, 3 divided by x? What's 3x mean? 3 times x. So, this is the part where we're undoing operations. What's happening to the variable? It's 3 times x, so we're multiplying it by 3 times x plus 2. So we have to undo multiplication, or we have to undo addition, right? So make yourself a little note. Undoing multiplication, undoing addition. Now, These kind of equations, we're always going to undo addition and subtraction first, remember? This I know you know, but we haven't done it in a while. So if it's adding to, the inverse operation is subtracting to, and always both sides. Good, whoever said that. We never do something to one side. When we're solving an equation, we always do the exact same thing to both sides. All right, so 2 minus 2 is 0, which leaves me 3x on the left. 8 minus 2 is 6. So I have 3 times x equals 6. So I have to undo that multiplication by dividing by 3. Very good. Some kids sometimes will start over here. Some kids absentmindedly, whatever, want to divide by 6. We always start on the side where the variable is. That's where we're always looking to find out what we're doing. So we're dividing both sides by 3. 3 divided by 3 is 1. X, 1x, there's my board, does not want to work. Maybe it's my pen, I don't know. Okay, so x equals 2, we're going to box that in. Example 2, can I combine anything on the right side? Yes. What? How many x's is this? 1x. 5x minus 1x is how many x's? 4x's. 5x minus 1x is 4x. And I didn't do anything to the minus 2, and you bring it down. 4 times x minus 2. Always undo the subtraction and addition first. How do I undo minus 2? Add 2 to both sides. So 6 equals 4x. 4 times x is the center root. 4 times x. So I undo that multiplication by dividing. And I'm going to wind up with x equals 6/4. Real quick, I want to remind you, you can simplify this using your calculator. 6 ABC 4 equals, what's that going to simplify to? 1 and 1/2. If you hit second ABC again, it will give you 3 halves. So either will work. It's 1 1/2 or 3 halves. Either will be acceptable. Typically, we give an improper fraction in algebra. Y'all caught up with me? Remember, this is going to be on video. If I happen to move a little fast, you can always fast forward to the part you need. All right. Nothing to combine on the other side here, but there are variable terms on both sides. So, trust me on this. What we want to do here, a couple ways to do it, but what we want to do every time is we want to move the variable term that has the smallest coefficient every time. Because we don't want to work with a negative number. Negative coefficients always come back, not always, but a lot of times messes up. So what we want to do, look at the coefficient, that's the number of the variable. This was a 7, this was a 3. Which one's smaller? 3. So we want to move that one. The way we move that is adding the opposite, and adding the opposite of a positive is subtracting. So we're going to subtract 3x from both sides, because that's what we do when we work with an equation. Same exact thing to both sides every time. So now I have an equation that only has variables on one side. That's 4 times x equals 2. And so how do we undo multiplying by? Dividing by 4, that's right. And when we do, you can put this in your calculator 2/4, and it will tell you it's 1/2. For the sake of time, I am popping along because I have 6 minutes. And they're going to start talking to me on these announcements pretty soon. Same thing in example 4. Variable term, variable term. This is smaller, so I'm moving it. It's a positive 5x. If I add another positive 5x, we'll have 10 x's over here. That's the opposite of what we want to be doing. We don't want more x's over there. We want less x's over there. So if there's 5 x's here, we're going to take 5 x's away, and we have to do it to both sides. When we do that now, 8 plus 0, which is just 8, we know. 7 x's minus 5 x's, this gives me 2 x's. I didn't do anything with this minus 2, I do need to bring it down. My operations I'm undoing 2 times x minus 2. Which one do we undo first, multiplication or subtraction? Which one do we gotta do first? Multiplication or subtraction? Subtraction. How do we gonna do subtraction? Adding. We're gonna add 2 to both sides. Add 2 to both sides. 10 equals 2x. And I'm speeding up because I'm running out of time. I'm dividing both sides by 2. And x equals 5. Got it, Lee? Remember, all you have to do to get full credit for these notes is write everything in writing. You're going to take these notes home with you. You're going to take and use it if you need it to finish that worksheet, that 0-1D worksheet. We're going to both back tomorrow. Okay. Variables on both sides, and also things like combine on both sides. Combine everything you can combine first, then get your variables together next. Then start solving. So what's 6 plus 2? 8. So my left side didn't change. I'm going to put my variable first because that's just what I like to do. But you can do 8 minus 5x if you want. All right, so now this simplifies to negative 5x plus 8. Now which coefficient is smaller? 4 or negative 5? Negative is always smaller than positive. So if we're going to add the opposite, what's the opposite of negative 5? Yep, so I have to add 5x, and we have to do it to both sides. 9x plus 7 equals 8. And for the sake of time, I'm about to bust this one all the way through because we're going to get to the last one. The last one is our one special solution example. Let's subtract 7 from both sides because we're going to do this addition first. And we have 9x equals 1. How do we end up multiplying by 9? Dividing by 9. And so our answer is 1/9. Have to do this last one. This is our one special solution. I will tell you. Special solution means the answer is going to be no solution or all row numbers. I have to combine these before. I know there's variables on both sides, but on the right side, I've got more than one term of the variable. So my left side is going to stay 9x minus 4 because nothing can be combined there. But I can combine negative 3x and positive 12x. When we combine those like terms by adding the coefficients, negative 3 plus 12 is 9, so it's 9x. And I didn't do anything with the plus side, so I bring it down. Now, when we look at this, we do have variables on both sides. Which coefficient is smaller? So we just add the opposite of whatever that is. Opposite of positive 9x is negative 9x, or subtract that 9x. So 0 minus 4 is negative 4. 0 plus 5 is 5. I don't have that. My variables have disappeared. Is that a true statement? It's a false statement, right? What's my answer then? No solution. There you go. If that were 5 equals 5, it would be a true statement, sorry, and our answer would be all real numbers. We got it all in. Thank God. All right, we are going to hold on to your notes. Starting tomorrow, we're probably going to start scanning and submitting our assignment. And I will work with you on that to make sure you know how to do it. If you need extra time, something happens, I will give you extra time this first week, and partly in the next week as well. Will be, I was pretty easy to get along with for a little while, okay? Let me know if you have any issues, if it's, everybody's good on being home, everybody knows what bus they're riding, all that jazz. Got all your RSC stuff? Good. Yeah, y'all can go ahead and put your calculators away.